Now I am going to explain about Gaussian random variable in two random variable case. Let us consider an n random variable xn where n equal to 1, 2, 3 up to so on n, and the joint density function of the Gaussian is given by fx of x equal to 1 by 2 power all to the power of n by 2, and determinant of cx all to the power of 1 by 2, and exponential minus x bar all transpose cx inverse x minus x bar by 2. Here Cx is called as covariant matrix, which is given by C11, C12 up to so n, C1n, C21, C22, C2n up to so on, Cn1, Cn2 up to so n, Cnn. And here x minus x bar is called as vector matrix, and it is given by x1 minus x1 bar, x2 minus x2 bar up to so n, xn minus xn bar. And here x minus x bar transpose, it is called as the transpose matrix of x minus x bar, and Cx, it is the determinant of Cx, and it is the inverse of Cx matrix. The joint density function for two Gaussian random variable x1 and x2 can be derived by substituting n equal to 2 in this equation. The covariant matrix for n equal to 2 is equals to C11, C12, C21, C22, where C11 equal to sigma x1 square and C22 equal to sigma x2 square, where sigma x1 is nothing but variance, and we know that rho, which is called as coefficient of variance, it is equal to C12 by sigma x1 into sigma x2, which is also equal to C21 by sigma x1 into sigma x2. By substituting these values in this equation, we will get covariance matrix equal to sigma x1 square rho x sigma x1 sigma x2 rho sigma x1 sigma x2 into sigma x2 square. And the determinant of this covariance matrix is given is equal to sigma x1 square into sigma x2 square minus rho square into sigma x1 square into sigma x2 square. By taking common, we get sigma x1 square into sigma x2 square into 1 minus rho square. And the inverse matrix of the covariant matrix is given by adjoint matrix by determinant. The value is equal to 1 by 1 minus rho square into 1 by sigma x square minus rho by sigma x1 into sigma x2 minus sigma x1 sigma x2 and 1 by sigma x2 square. And by substituting n equal to 2 in the vector matrix, x minus x bar, which is equals to x1 minus x1 bar, x2 minus x2 bar. And here by substituting these values in this equation, we will get this equation. By multiplying the equations, we will get this equation, and substituting this value in this equation 1, we will get the joint density function for two random variable case, so which is equals to f of x1 x2 of x1 comma x2 equal to 1 by 2 pi sigma x1 sigma x2 under root of 1 minus rho square exponential of 1 minus 1 by 2 into 1 minus rho square into x1 minus x1 bar whole square by sigma x1 square minus 2 rho x1 minus x1 bar into x2 minus x2 bar by sigma x1 into x2 plus x2 minus x1 bar whole square by sigma x square. Thank you.